Today is lesson 3.2, use parallel lines and transversals. Today is the 28th of September. By the end of this week, we will have finished chapter 3, and we'll be on fall break. Yay for us. Okay. So we're going to apply the postulate and theorems for angle pairs made by a transversal and parallel lines. So on Thursday of last week, we talked about as long as there is a transversal, you get alternate interior angles, alternate exterior angles, consecutive interior angles, and corresponding angles. There's nothing particularly special about them when the lines aren't parallel. When they're going to intersect, there's nothing particularly special about them. But today our lines are going to be parallel. So if they're parallel, then something is going to happen that's special about them. And the first one out is we're going to talk about corresponding angles. So remember, corresponding angles are in the same location. So they're both to the right of the transversal and they're both above the line. So in this case, they're both above a parallel line and they're both to the right. Now they could both be to the left. They could be to the left and below. They're just in the same corresponding location. Because they are in the same corresponding location, they will end up being congruent. So, number one, if parallel lines are cut by a transversal, then the corresponding angles are congruent. Now let's look at yesterday. Here's two lines. They are not parallel. And when I put in a transversal, I guess I should make it look like the original picture a little bit more. Sorry about that. So here's two lines. They are not parallel. And here's a transversal. If you look at the same corresponding angles, we'll just call them 1 and 2 again, you can see that one of those is obtuse and the other is acute. So they're not going to be congruent until the lines straighten out and become parallel. So all of today's postulates and theorems are because the lines are parallel. So you'll notice all of our if-then sentences start with, hey, you already know the lines are parallel, so then what else do you know? You already know the lines are parallel, so then you're going to know that the angles are congruent. But you have to be specific about which angles. So this one mentions the corresponding angles. The second one talks about the alternate interior angles. So we already have angle 1 and 2 and they're corresponding, and 2 is the only interior angle. So I am going to give you its matching alternate interior angle. Now we already know that angle 1 is congruent to angle 2 because they were corresponding. The first postulate already said that. I also know that angles 1 and 3 are congruent because they're vertical angles. So if two angles are congruent to the same angle, that makes them congruent. So I've now proven the theorem, which is sentence number 2. If parallel lines are cut by a transversal, then the alternate interior angles are congruent. So angles 1 and 2 were congruent because they were corresponding, and now angles 3 and 2 are congruent because they're alternate interior. Remember, postulates and theorems are shortcuts, and that's why when I give you all those sentences, why can I shorten it down to that? Because it's a theorem, it's a shortcut. Okay, let me remove all that stuff. put back what I need. Okay. So first one's a postulate. If two parallel lines are cut by a transversal, the corresponding angles are congruent. The second one's a theorem. If parallel lines are cut by a transversal, then the alternate interior angles are congruent. The third one, if parallel lines are cut by a transversal, then the alternate exterior angles are. So we already know we have angle 1, which is an exterior angle. So I'm going to put in angle 4, which is its alternate exterior angle. And let's go back to what we know again. We know that angle 1 is congruent to angle 2 because they were corresponding angles. We know angles 2 and 4 are congruent because they're vertical angles. So if two angles are congruent to the same angle, then they are congruent. Remember, congruence of angles is transitive. So now that means angle 1 and angle 4 are congruent. So how do we shorten all of that? We write it as a theorem. If parallel lines are cut by a transversal, then the alternate exterior angles are congruent. Let's get all that out there. So then the next one is about consecutive interior angles. And at this point, I have no consecutive interior angles. So consecutive interior angles are, let's do, we'll use number 2. Okay, and so number 2 and angle 5 right there, those would be the consecutive interior angles. And let's do what we know again. And I'm going to move 3 and 4 out of the way so they don't cause, oh, sorry. Apparently 1 and 3 are attached. So we know that angle 1 is congruent to angle 2 because they're corresponding angles. We know that angle 1 and 5 are a linear pair. So they add up to 180. So if 1 and 5 add up to 180, and I substitute angle 1 with angle 2 because they were congruent, they were the same, I could substitute them, then that means angles 2 and 5 also are supplementary. So again, do I want to keep writing all of that? No, there's a theorem that says if parallel lines are cut by a transversal, then the consecutive interior angles are supplementary. So we're going to review this one more time. The first one is a postulate. If you have parallel lines and you're talking about corresponding angles, they will be congruent. Number 2, 3, and 4 are all theorems because I had to prove them. If you have parallel lines and you're talking about the alternate interior angles, they will be congruent. Number 3, if you have parallel lines and you were talking about the alternate exterior angles, they are congruent. And number 4, if you're talking about parallel lines and the consecutive interior angles, they are supplementary. You can definitely see that they are not congruent. One of these looks like it's acute, while the other one is slightly obtuse. So they're definitely not congruent. They are supplementary. You'll notice that you have another theorem here that says if two lines are parallel, ignore that one. We're not going to talk about that one. I do that later on in a later lesson. So we're not going to look at that one. Sorry about that. We'll just You can just cross that out. That's going to be talked about later. We're just going to concentrate on these four. We're going to look at a variety of types of examples. Our first example says, state the postulate or theorem that makes the statement true. So I don't even have to decide if this is true or not. They are telling me it's true. They have told me that I have two lines that are parallel. You can see that through the arrows right here, so we know they're parallel. They are also telling me that angle 1 is congruent to angle 2. So of my four theorems, I need to figure out which one applies. So first and foremost, are these alternate interior angles, alternate exterior angles, consecutive interior angles, or corresponding angles? Correct, they are alternate interior angles. So which postulate or theorem talks about alternate interior angles? It is the one that says, whoops, that's in my way. If parallel lines are cut by a transversal. Why do I start the sentence that way? Because I start with what they gave me. They gave me parallel lines. So if you think about it, this was the if, this was the then. Okay. So if two lines are parallel, or if parallel lines are cut by transversal, then we don't say then the angles are congruent. We have to name them. Then the alternate interior angles are congruent. And you can abbreviate alternate interior, alt-int angles congruent. And that's all just shorthand because that's a lot of writing and it gets kind of tedious. Okay, so what's the postulate or theorem? If parallel lines are cut by transversal, then the alternate interior angles are congruent. So the next type of example says find the measure of angle 1 and state the postulate or theorem. So you may want to actually figure out what the postulate or theorem is first for it to make any sense. And so what did they give us up front? They gave us parallel lines. So if parallel lines are cut by a transversal, then, okay, so now we have to decide what we're looking for. Are we looking for angle 1 or angle 2? It says angle 1. What value do you know? 115 degrees. So are those corresponding, alternate interior, alternate exterior, or consecutive interior? Correct. Then the consecutive interior angles are, and this is the only one that's not congruent, they are supplementary. Okay. So you can abbreviate or you can write it out. Now that we know what postulate or theorem we're using, we now know if we need to add these together or to set them equal. Remember earlier in the year, I told you that 90% of the time we set things equal, and this is one of those times when we don't. We're going to take the 115, we're going to add the measure of angle 1 to get 180 degrees. Because the consecutive interior angles are supplementary, so the measure of angle 1 is equal to 5 makes it 20, so 65 degrees. So it doesn't matter if you find the angle first or state the postulate or theorem first, you just have to do both. We're going to kind of continue in the same vein, except now we're going to look at a situation where part of the angle is missing. Not all of angle 1, but part of it. So it becomes an expression, but it's still the same. We're going to calculate the value of x, and we're going to state the postulate or theorem used. Again, I am going to really push for you to write the postulate or theorem first. only because if you can identify that up front, then you can do the algebra a little easier. Otherwise, you're repeating yourself, so why not just get it done? Okay. So what do we know? We are given that the lines are parallel. So if the lines are parallel, then, so you decide, what are these angles that they have given you? Are they corresponding, alternate interior, alternate exterior, or consecutive interior? Correct. They are alternate, sorry, they are corresponding. Whoops. So if parallel lines are cut by a transversal, then the corresponding angles are congruent. Now, normally, sorry, I stopped so you could write. If parallel lines are cut by a transversal, then the corresponding angles are congruent. So if these two angles had a name, we would say angle 1 is congruent to angle 2. And then we would say the measure of angle 1 equals the measure of angle 2. But these angles don't have a name. So this is not required because we don't have a name. So our geometry, our initial equation, is going to be 135 equals x minus 30. Because the angles are congruent, their measures are equal, so we're going to set them equal. So then we're going to add 30 to both sides, and x is 165. Not 165 degrees, because this x is not the angle, it's part of the angle. Number 2. Wow, my pictures are huge. Okay, so number 2, again, what did they give us? They gave us parallel lines. So we already know if parallel lines are cut by a transversal, then, so now you have to decide the angles they gave us, are they corresponding, alternate interior, alternate exterior, or consecutive interior? They are both between the two lines, so they're both interior. Are they on the same side or opposite sides of the transversal? Correct, same side. So I want you to write down the theorem that would work for this. If parallel lines are cut by a transversal, then which angles are what? Go ahead and pause the video to get that done. Good, I hope you remembered that if parallel lines are cut by transversal, then these are consecutive interior angles and they are supplementary. So go ahead and pause the video again, and I want you to write the equation that goes with that theorem. So you should have 3x minus 1 plus 31 equals 180 degrees. Again, these angles are not named, so I'm not going to start with an equation with names. I'm going to add like terms, so I get 3x plus 30 equals 180. I'm going to subtract my 30, so 3x equals 150. And then we're going to divide by 3. So x is 50. Again, it is not x equals 50 degrees because x is not describing the entire angle, just part of the expression. Our last example is a little trickier, but it's okay. We can handle it. So what did they give us? Good, parallel lines. Where are those angles? Are they corresponding, alternate interior, alternate exterior, or consecutive interior? You're right, it's none of those things. So how do we get this to work? Well, remember, in chapters 1 and 2, we had vertical angles and linear pair. They still apply. They always apply. If you can apply them, apply them. So I am going to go ahead and apply vertical angles because they're a little easier to apply in my mind. Doesn't mean that's what you have to do. So I'm going to move the number that I know, it's 112 degrees, and I'm going to move it into its vertical angle position, which is right here. So now, where are these two angles? The 112 and the 2x. I'm going to redraw that picture because I know it does get a little smushy. So this is the 2x plus 12, and now this is the 112. So where are those angles? Good, they're consecutive interior angles. So in this case, when it says solve for the value of x and state the postulant or theorem used, there are actually two of them. The first one is, if two angles are vertical angles, then they are congruent. That's how we moved the 112. Then we went to, because the lines were given as parallel, we moved to the theorem, if parallel lines are cut by a transversal, then the consecutive interior angles are supplementary. So that's where we ended. So that's what tells me what the equation is going to be, because we ended with the word supplementary. So that tells me that I'm going to add these two together somewhere up here. Sorry about that. So we're going to add these two together. So 2x plus 12 plus 112 equals 180. And again, please pause the video. I know it's a little hard because you're not out there with me and I'm not sure about the pacing. So please feel free to pause the video. So then we're going to combine like terms. 2x plus 124 equals 180. Then we're going to subtract our 124. So 2x equals 56. And then we're going to divide by 2 and x is 28. So one more time, I moved my 112 using vertical angles. So if two angles are vertical, then they are congruent. And now that I knew that this interior angle on the right was 112 as well, then I moved on to, if parallel lines are cut by a transversal, the consecutive interior angles are supplementary. And since I ended with supplementary, that tells me what my equation is. Add them and set them equal to 180. So that's the end of today's lesson. Don't forget to email any of your teachers if you have any questions. And you will be taking a quiz on Thursday over chapter 3. A quiz on Thursday over chapter 3.